Okay. So Java 8 is an interesting major advance within Java. It introduced a set of features that have been requested for years for those from the functional language community for Java, and does so in a way that is simultaneously compatible with traditional Java, but very powerful. It is not quite as syntactically sweet and succinct as in Scala, but it's still worth note. And Java 8 and beyond is making and will be making heavy use of these innovations within the Java language. So Java 8 supports declaration of anonymous functions and function types for variables. Much as in Scala we can have a parameter that's a function, like a parameter we pass a map, right? That's a function. Or a parameter we pass a filter, that's a function as well. We can declare similar functions within Java 8. And Java 8 distinguishes functions of several sorts, sort of those that take no arguments, those that take a single argument, and multiple arguments from each other. And then it uses this terminology operator. Here, an operator is something that takes in and returns the same type of value. A consumer, which is something that takes in a value and it consumes it. It doesn't actually put something out. It returns void in Java terminology. A function, which maps one type to another type, and a predicate, which returns a Boolean type. So where would you use a predicate, for example? What sort of higher level function would we use a predicate for? Filter. Yeah, filter would use a predicate. So this is the kind of syntax which is used in Java 8. So for example, we might have a binary operator here. As an operator, it takes in and returns the same type of thing. And it is, what's this thing with the less than t and greater than sign? Generic. Yeah, it's a generic. What this is saying is it's type parameterized by t. So a binary operator, you can have a binary operator that operates on strings, or operates on doubles, or operates on ends. Binary operator for strings would take in a string and a string, and it would actually return a what? String. A binary operator for ints would take in pairs of ints and return an int. Okay, actually be a reference to an int rather than the primitive type int, because it needs to be boxed. It needs to be a reference to an object, but that's what it takes in. Similarly, you might have a function from t to u, which takes in a t and returns a u, or a by consumer, which is parameterized by two types. It takes in those two types and it just consumes them. It just eats them and it doesn't return anything. It processes them. Maybe it uses them to send off a network message or update a screen, perform some side effect. Okay? So these are examples of functions that we can define in Java 8. And we can define anonymous functions in Java 8, much as we have done in Scala. In Scala, we indicate an anonymous function using a syntax that I hope you've come to appreciate, if not love. So, we can say val, my fn equals, and here I'll write it in parens just so it's clear, a to a plus 1. Okay, come on. Yeah, fine. Come on. Oh, man. Fine. There's an anonymous function here in Scala. It's an anonymous function that takes in an integer and returns back a value. Here, within Java 8, we can create similar constructs using this notation. So this takes in an a and a b, and it adds them together, right? You'll notice that when we define it that way, just as in Scala, there's some type inference which can take place as to the types of A and B. In some cases, like what you just saw, the language may be truculent. The compiler may be truculent and say, okay, you need to specify the type, okay? And in other cases, it may be able to figure it out from context. When might it be able to figure it out from context?
When you're calling int functions.
Yeah, when you're calling things, maybe you're saying reduce, for example, on a vector of ints, right? And it knows, okay, to apply a reduction operator on this vector of ints, it requires a function that operates on pairs of ints. So it, on, you know, two ints. And so it knows, okay, A and B have to be ints, right? This last one, what does this one do? What does this do? Yeah, it's a, is it a consumer?
Just prints a stack.
Yeah, it is a consumer, but it's a particular weird type of consumer in the sense that it doesn't consume anything. It's a consumer that requires no arguments, right? And it prints something out. This, so it performs the side effect, returns void. It doesn't return anything. But this is a function. It's just a function which takes nothing as an argument. So they go by various names here. You know, consumers, we talked about return void. There's a thing called a supplier, which takes nothing, and it returns a T. Okay, and so its job in life is to return values, right? And we talked about some of the others, and they're sort of the arity here with taking two things, for example, with these by potentially returning something of different type. Now, operating in this way in Java 8 is more cumbersome than in Scala, because Java 8 has this, just like Java historically, has this distinction between boxed and unboxed versions of many primitive types. Is that notion of boxing, is that something you've heard before? Okay, no? Okay, so with boxing, basically, we can have an integer just by itself as a value held in a variable in Java, or we could have this actually as an integer, an instance of an integer type, in which case it's an object referred to by a variable. Okay? And you can only type parameterize things by classes, and this is a class that holds this value of a double. And in Java, when we use the primitive value, we say double v, right? If we want to have a boxed version of this, so one that's actually referring to an instance of a double, what do we use? Capital double, you know, of v. This is actually going to be a reference to a thing that holds a double, a lowercase double, but this first one with a lowercase d is going to actually hold the value itself, right? Okay, so partly because of that awkwardness, because when we type parameterize something, we need to do so with a class, and you can only do that with a capital D double. Java 8 basically supports a bunch of specialized types for these built-in ones that don't need to be type parameterized and therefore can operate on unboxed values like lowercase d double. So you can have you can see it says T to U function. What this really is something like int to double function, or double to double function, or int to long function. And this will take in an int in a lowercase sense, an int, an actual value, and it will return, say, a long with a lowercase l. So this actually operates on the primitive values, not on references to objects that hold those values. And that saves memory, amongst other things. Or you can have an int supplier, which takes in nothing. It's just a function that needs to be called, and it returns an int, as in lowercase I, so it's just the value. It doesn't return a reference to a value. Similarly, you could have an int binary operator, or a Boolean binary operator, or what have you. So then these specialized versions of these that mean you don't have to take these sort of standardized functions and always parameterize them by capital D double. Instead, you can use many of these for your common day-to-day needs, and they operate very conveniently on the actual values. Okay, so Java 8, that's a little bit of a sort of side issue, but it helps increase performance. Okay, so here's an example of declaring an int binary operator. Here we can optionally declare it with full type information, or we can declare it as an anonymous function without full type information, but it knows, wait a minute, this is an int binary operator, so I has to be int in a lowercase sense, an unboxed, one that's not boxed up in a value, it's just the actual primitive. B is the primitive, and it returns back I int, lowercase I int in the standard way. Okay, I'm not going to go into this in too much detail, but if you have, for example, an int unary operator or a double unary operator, you can compose them with other such operators, and with a similar types of thing with a predicate, say an int predicate or a double predicate or a person predicate. Basically, you can AND it together with other predicates to create composite predicates, predicates built out of ands and ors of other smaller predicates, or you can test it against the appropriate type. So if this is an int predicate, it would test ints. If this is a person predicate, it would test persons for whether or not they pass some criteria. That's what a predicate encodes, and we talk about it as matching the so-called specification pattern. Java 8 functions can be created in a number of ways. One is we can create them with anonymous classes. We can explicitly instantiate instances of these methods. We can use lambda expressions, which is the name applied for these sorts of operations. This is a lambda expression, it's called, and I think for those who have taken the course on Haskell, maybe you get some exposure to why that is with the lambda calculus. Or you can just name a class and just say C : method name. That's referring to this method in class C. And if it's a static method, it says, oh, that's a function. I can treat that as a Java 8 function and pass it around. If it's not a static function, if instead if it's not a static method, if it's a method that is not static, by implications it operates on an instance of class C. You do, C.foo. If you have C.foo, it's implicitly taking whatever C is as its first parameter, is the idea, and so we can treat that as a function as well, taking one parameter, the value of C. Okay, so we can pass it around as if it's a function, taking only a certain value. So here's an example using named functions. So I might have, for example, a static function called foo, a non-static function called bar, and this is all inside my class. So if I had an instance of this class, I could call it m. I could call m.bar, pass it a value, and get back some value. Now here, if I then want to return back values, one way to do this that are of this type is I could actually go and return here, like legit return 1. I could return foo, a static value as if it's an int unary operator. Okay, it takes in a value and actually returns a value back. Alternatively, I could here return. I could return a method that takes in a value. So here bar here takes in a value and it returns an int, and I could return that as a function as an int unary operator. It's operating on whatever values passed to it, and I do so with this. So whatever is the current value of this, when I call legit return 2, it uses that as the instance on which bar is called here. Alternatively, I could return baz here as a function, but what it will be doing here is that's a function that takes in an instance of this class and returns an int. Why? Because you need to call baz on an instance of this class, because it's not static. It is something that needs to be called on an instance of my class for functions. Okay? So these are all different ways that I could create a function in Java 8 from an existing method here. Not absolutely critical that you picked up all of that, but it's just worthwhile to note we can create functions not only in this lambda expression way by returning existing functions, and there's some subtleties as to what they take implicitly as an argument if it's a non-static method. Okay, so here, for example, we have a call to here info. Okay, there's a call to info up here, and I'm calling info on a logger, and info requires be passed to it a function. Okay, I'm passing into it a function that does this work if it is called. Why might I call that on a logger? Why not just create this string and pass that to the logger? Why pass in a function that needs to be called to do this work? What is it about logging that goes on that's different from your average function call? Those of you in 371, with logging, what can you do with logging? Okay, why is this called info? I'll give you a hint. Sometimes we might alternatively call on the logger not just info, but we might call debug on a logger, or we might call error on a logger, or we might call warning, or we might call critical. What are those all indications of?
Levels.
Yeah, levels of logging. The level may be associated with an exception, it's a very serious one, etc. The point here is with a logger, we don't always want everything to be logged, right? Sometimes we want only more serious things to be logged. Sometimes everything to be logged because we're in the middle of debugging, right? Maybe in the midst of testing, we want everything to be logged. But when we are running this in a production way, we only want errors and warnings to be logged, right? The point is that we alter what we want to log at runtime even, without recompiling. We want to be able to run our program and say, ramp up the logging so I can see in detail what's going on, or ramp it down so I only see highest level messages. Now, why does it help? I'm giving you a hint. Why does it help for that purpose to be able to pass in a function instead of just a message? Why not just always log a message?
It's disabled, you don't have to compute it.
Exactly. That's exactly it. So ladies and gentlemen, here's some work that's being done. And this work is pretty modest. We're getting the current time and turning it into a string, and we're putting it together with some other information. But in general, with logging, what's being logged it could require a fair bit of effort to sort of cobble together the message that needs to be put out. And if you're not logging at a level that requires that, why do that work? Right? Why go through all this work, which here is modest, but can sometimes be intensive, if we don't need it? After all, we may not be logging at this level right now. So by going through all the work, passing it this string, saying, okay, finally I got your string for you, and it just throws it out, that's not really that useful, right? What's much more useful is for info or debug or critical or warning to take in a function. There, the work to build up the string only gets done if what? If the function is called. And info, if we're not logging at the level of informational messages, we'll just never call that function, right? If we were calling this debug, if we're not logging at the level of debugging messages, we never actually call this function. So we never actually do the work. If we had to pass a whole string to it, we always have to create that string only to find that it's actually not needed in the end. This provides a way of sort of throttling the amount of work we have to do based on the amount of logging we have to do. If we're not going to need it, it just never calls this function, and we never actually have to do this work. Does that make sense? I want to make sure that sinks in to people, because it's an important use of functions, whether in Scala or Java 8 or whatever, but it's one that you see in spades in some areas of programming. And with the logging in Java 8, this is an important feature of it. If you go look at Kay Horstman's book on Java 8 for the impatient, this has maybe 2 or 3 pages associated with it. So the point is that here, one of the advantages we get out of passing around closures is, particularly for something like logging, we don't have to do the work unless it's needed, until the closure is called. So this wraps up this work to be done in a closure. And if that closure is called, great, we do the work. If it's never called, we never do the work. Yeah. Okay, so Java 8 here, we are passing in a closure that takes nothing as an argument. In other words, we just call it, it does it. It doesn't need anything to do the job. We just call it. And then it will return a string, right? And so if you look at the declaration in Java 8 for info, this is given a supplier, right? This is a supply. This is a function. Its job in life is to supply a string. It takes nothing as an argument. That's what a supplier does. It takes nothing. So this supplier, we saw that earlier, is one of these specialized types, right? It takes in nothing and it returns that. So this is a supplier of strings, so it takes in nothing and returns a string, and that's exactly what we are giving it here. So that supplier is being created by the synonymous function. Do you see that? So the key point here is in Java 8, we have this awkward syntax for saying, okay, I need a function of this sort, and it's kind of a specialized set of functions, but we can create them really, really easily using the synonymous function syntax. This is just like in Scala writing, begin paren, end paren, equals greater than, right? And it's just the Java 8 way of writing a lambda expression, writing a function, right? So it's exactly this sort of thing in Java 8. Okay. So let's continue on here. I don't have time to skip this because I want to get to some other things. Just be aware that there's no magic here, ladies and gentlemen. There's still activation records. If foo calls bar and bar calls something else, we cannot have this thing that is called at the end here, create increment by, magically remember, close over, remember values passed to it from bar unless they are constant and final, unless they are final methods. So we can't have it sort of remember internal local variables of bar which go away after bar returns as well. Okay, don't have time to go into this. But the point is that when we have closures and we return closures, they remember information. That's right. They're not just a function. They're a function that knows about certain information, that retains state. It remembers certain things, remembers certain information. And there's limitations in Java 8 what it can remember within the closure, what it can sort of capture and retain and use after it's returned. Basically, there's a lot of limitations. It can use final values that are constant. Okay. Type inference is key in Java 8, just as it is in Scala. Sometimes it doesn't succeed, like this case. I tried to do this and it couldn't succeed. In other cases, it would, right? In Scala, if I said if I just said vector, this vector of nice numbers again here, and I did filter, right? Here it's going to actually allow me to test. Okay, I want to return ones that are greater than this, right? It can do so without naming the type of this because it knows this is a vector of doubles. Therefore, A has to be a vector of doubles. That's an example of type inference, right? It figures this out. Whereas if I tried to say this is a function here by itself without that context, if I tried to say val my function 2 equals this thing, it's going to be a pretty unhappy camper because it'll say, I don't know what type it is. Here it knows what type it is because it's being applied to a vector. So it is with Java 8. There's a lot of type inference that goes on to figure out these types. Okay. I think I will leave that, and I'm going to go on here to the next major type of thing which I want to talk about, which is Java 8 streams. Okay, and I'm going to stop this recording, and we're going to go on to the next one here. So here we go, and save that.